Welcome back to our explainer on JavaScript. So, you've seen how JavaScript can compute and evaluate expressions. Now, it's time to bundle all that raw power into reusable blocks of logic. We're talking about functions. Honestly, these are the engines that make your code organized, efficient, and, well, smart. And hey, don't just take my word for it. The Mozilla Developer Network, pretty much the authority on this stuff, says it right there. They are one of the fundamental building blocks. Once you really get how these work, you'll start seeing them absolutely everywhere, powering every single part of the language. So we know they're important. Let's map out exactly how we're going to tackle this. Here's the game plan. We're going to start with the why. Why do we even bother with functions? Then we'll get into the three main ways you can define them. From there, we'll dive into how they handle inputs, and then get into the really fascinating stuff: scope, memory, and closures. We'll finish up with a couple of advanced patterns and take a look at the toolkit JavaScript gives you for free. Okay, so let's start at the very beginning. Why do functions even exist? I mean, why can't we just write one super long list of commands and call it a day? Well, the answer is all about structure and, frankly, sanity. Functions let us organize our code into neat, logical chunks. They are the ultimate weapon against repeating ourselves, which is a core idea in programming called the DRY principle: don't repeat yourself. By giving a name to a specific job, we create this reusable recipe that we can call on whenever we need it. It keeps our code so much cleaner and easier to manage. All right, now that we've got the why down, let's get into the how. JavaScript gives us three main ways to create a function, and each one has its own little quirks and best use cases. First up, we've got the classic, the function declaration. You just use the function keyword, give your function a name, and write your logic. Now here's the really unique thing about them: they're hoisted. This means the JavaScript engine, before it even runs your code, kind of looks ahead and pulls these declarations to the top of their scope. So you can actually call a function before you've technically defined it in your file. Kind of weird, but can be useful. Next, we have the function expression. This is where we create a function and assign it to a variable. And here's the crucial difference. Expressions are not hoisted. The variable greet might be known, but its value, the function itself, isn't assigned until the code actually hits this line. This gives you way more predictable control, preventing you from accidentally calling a function before it's ready. And finally, the modern, sleek arrow function. It came along in ES6, and everyone loves it because, well, look how short and clean that syntax is. But its real superpower is how it handles the this keyword. Unlike the other two, arrow functions don't have their own this. They just inherit it from whatever context they were created in, which solves a whole category of very common bugs, especially with callbacks. So let's just quickly sum that up. As you can see here, the big differences really come down to hoisting and the this keyword. Declarations get hoisted, expressions and arrows do not, which gives you predictability. And, crucially, arrow functions have that lexical this binding, making them perfect for things like short callbacks. Choosing the right one is all about understanding the context of your code. Okay, we know how to define them. Now let's make them truly useful by passing them data. It's time to master how functions handle their inputs, their parameters, and arguments. This slide is just a perfect example of how much better JavaScript has gotten over the years. Look at the old way. If you wanted a parameter to have a default value, you had to write this clunky manual check to see if it was undefined. Now, with ES6, you just assign the default value right there in the function definition. It's so much cleaner, more readable, and way less likely to cause a bug. But what happens when you don't know how many arguments your function is going to get? That's where REST parameters are an absolute lifesaver. That little three-dot syntax lets you gather up any number of arguments into a single true array. This is so much better than the old arguments object, which only looked like an array and was a pain to work with. Okay, we've covered the mechanics. Now we get to pull back the curtain and explore the really cool secret life of functions, how they manage their own little universes of variables, memory, and state. We're talking about scope and closures. Everything, and I mean everything, starts with this one concept: lexical scoping. It sounds complicated, but the rule is actually pretty simple. A function's scope is determined by where you write it in your code. It's like it carries a little backpack with it. And in that backpack are all the variables that were around when it was born. And this is the key to everything. So how does this so-called magic actually work? It's really just a four-step process. First, you have an outer function that defines some variable. Second, that function returns an inner function that uses that variable. Third, you call the outer function and save that inner function it gave back to you. And now for the magic, even though the outer function is completely gone, finished, poof, the inner function remembers its original home. That combination, the function and its memory, that's a closure. Building on that amazing concept, let's check out two powerful patterns that you'll definitely see in the wild: the immediately invoked function expression, or IIFE, and the elegant idea of recursion. An IIFE, which you'll sometimes hear called an IIFE, is basically a function that runs itself the moment it's created. You wrap it in parentheses and then call it right away. The whole point, historically, was to create a private little bubble for your variables so they didn't leak out and mess with the global scope. Now, modern JavaScript with its modules and block scope has made IIFEs less necessary, but you'll still see them, and the idea of isolating scope is still super important. All right, now for a pattern that can feel a little like a brain teaser at first, but is incredibly elegant once it clicks: recursion. This is simply when a function calls itself. The whole trick is to take a big problem and break it down into smaller, identical versions of itself. The function keeps calling itself on these smaller pieces until it hits a base case, a condition so simple it can just give an answer without calling itself again.
And this is the perfect way to visualize what's happening inside the engine's call stack. When factorial 3 is called, it can't finish its job yet. It pauses and calls factorial 2, which then pauses and calls factorial 1. That's the base case. It immediately returns 1. Now the chain unwinds. Factorial 2 gets the one it was waiting for and returns 2. Finally, factorial 3 gets that 2, calculates the final result, and returns 6. It's like a stack of plates that you build up and then take down one by one.
Now, you might be thinking this is all just cool theory, but the truth is, you've been using these concepts all along. They are the foundation of the massive toolkit of functions that JavaScript just gives you right out of the box. I mean, seriously, think about it. Every single time you use math.random, or you call .uppercase on a string, or you use those amazing array methods like .map and .filter, you're calling functions. These are just pre-written, highly optimized recipes that follow all the same rules of scope, parameters, and execution that we've been talking about this whole time. So, to wrap it all up, functions are where JavaScript's logic truly comes alive. They are logic, packaged up in a neat, reusable form. But all that logic is kind of stuck inside the engine. To actually interact with a real world, the web page itself, it needs a bridge. And in our next explainer, we're going to explore that bridge, the DOM. But before you go, I want to leave you with something to think about. We've seen how closures give functions this incredible memory. So how could you use that memory to create variables that are totally private and protected, only accessible through specific methods you create? It's a really powerful pattern, and it all starts with what you learned today. We'll see you in the next one.